Hello and welcome back to the Accessing Data with Cursors in ArcPy overview. In this section, we are going to take a closer look at the insert cursor. Remember from before that the insert cursor is what allows us to create new data. It establishes write access to our data and what allows us to add new rows to our data. It is essentially opening an edit session for our data set where we can add new features to a feature class. Like search and update cursor, accessing the return cursor object is most often done in a for loop so that we can iterate through all of the items and add all of the rows that we want to add to the data set. And again, as we've mentioned before with all of our cursors, we are using the with statement is in order to ensure that all data locks are released and our cursor object iteration is reset to the beginning at the end of every script or whenever a script might fail and bail in the middle. So here's our detailed look at the syntax for insert cursor. Take note of the short number of parameters here, and also take note that it looks like there are 3 required parameters here for insert cursor. However, I want you to note that the datum transformation is actually not a required parameter. I believe right now this is just an error in the documentation online, but do know that, and you'll see as we go through here with insert cursor, that it is not a required parameter when you are populating a new table or a new feature class with items with insert cursor. All right, so now that we've talked about that, let's talk a little bit here about the things that are required. An in table, which should seem very familiar to you by now with all of our cursors, this is the data you wish to access. Typically, if you're doing this in ArcPy, this is going to be a shapefile or a geodatabase feature class. The other piece of information that's required is a tuple of field names from your data set. This is the data you wish to access within your data set, all of the fields you wish to access. And here are all of the field name, and within that will be all of the fields that are going to be accessible to your insert cursor. You will only be able to place your cursor inside the fields that you list here within this tuple. One thing of special note for insert cursor, because remember we're doing an edit session, which means we're not just adding or updating field information. If you add an entire row to a GIS data set, you're also adding feature geometry. So we have to be able to add the geometry of the individual feature or row we're adding. The way this works with insert cursor is through something that's called the geometry token. For any insert cursor that you do within ArcPy into a data set, you need to have a geometry token. What this is doing is it's telling the insert cursor what part of the shape object to open in order to have access to it. So here I've highlighted the most popular geometry token, the one that we will be using in class, which is the shape at XY, which allows you to add a new point feature to a data set. So it will contain an XY coordinate that you will be adding to your shape field in the data set. Before we move on further, let's talk a little bit more about the geometry token and how we use it to work with data geometry within ArcPy. Knowing GIS data, specifically feature data, those points, lines, and polygons, you know that the geometry of a data set is stored in the shape field. And the shape field is what tells you what type of feature class it is, whether it's a point, it's a polygon, or, and you'll see polyline here, just remember that line and polyline are the exact same thing. It is within the shape field that you see that. In order to add new records to a GIS feature data set, you must also add the geometry here to your code, and that's where the geometry token comes in. So your insert cursor is going to populate the shape object as well as your attribute fields. And you'll see this here. This is a snippet of a line of code that is using insert cursor. And we can see here that our in table is something called Fires 2018. I know that it's a geodatabase feature class. I'll pause for a second. Do you know why I know? All right, if you just thought in your head, well, it's missing the .shp on there that would indicate a shapefile, then you're correct. If you see an insert cursor with a data set that has no extension, more often than not, it's going to be a geodatabase feature class. If you see the .shp extension on here, you know that you're working with a shapefile. So there's the in table, and then the next piece of required information was that tuple of my fields that I want to have open within the cursor. The first one is always going to be our shape object, our geometry token. And for here, it says shape at XY, so by looking at that, I know that this line of code is only going to be adding a point to the data set, an XY coordinate. And then we have 4 additional fields here that from these would exist currently within FIRES 2018. Incident name, feature category, map method, and create date are fields that exist in this data set that we want to have open in the cursor so that we can insert information into each of those fields. So why do we have this shape at XY, this geometry token? Why don't we just, put shape in here and have the entire shape object open within our ArcPy code? Well, it's been learned over time that opening up the entire shape object is considered an expensive operation, meaning that it takes up computer processing time and space. And Esri has learned that if you can isolate the shape, the geometry token on the shape that you want to have open and you want to work with, it just makes your code run a lot faster and a lot more efficient. So again, here I just highlighted these are some of the shape objects that you would have available to you, and more often than not, the shape at XY is one that gets used quite often with an insert cursor. So also with insert cursor, just like you've seen with search cursor and also update cursor, it has a series of methods that are available to it. Actually, there's only one method here for insert cursor that's available, and it's the insert row method, and very clearly it inserts a row into the table. So you can see that it has one parameter here. This parameter is actually just a variable that you're going to populate with a tuple of the list of fields that you want to update within your insert cursor. So within this tuple here will be a list in the same order from your insert cursor statement of the fields that you want to have populated, but it will contain the information to be put into each of those fields for the row that you are on. Here is a brief little snippet of the insert row portion of a code, where here we are populating a variable that this code has called row value, which is the same as row. So this is my reminder to you that this parameter here is simply a variable that you can call anything. So our row value is equal to, the first thing here has to be what's going to be put into our geometry token, our shape at XY. So we've stored in a variable called longitude and latitude the X and Y coordinates for this particular row. And in these 4 variables, we have stored the individual information from somewhere, more often than not an additional table, that we want to populate into the name field, category field, method field, and date field. We just have the text to be inserted, stored in a variable here. Oftentimes you'll see that we print out also that row value after we create that tuple. That just allows us to see that for the record it's on, that there's information in that row. Because if you start to see odd things print out here, you know that your data might often look odd as well. All right, then the thing that actually inserts this into your table, into your data set, is the cursor.insertRow method, where it's going to use the information being held in the row value variable, which is this tuple of information here of fields. As we've seen before, there are often additional ArcPy tools that are used in the scripts that also use our cursors. So we've talked about this with each of the cursors previous to this. Oftentimes, our cursors are used in a broader project. So we're not just writing a script to do just this one thing. It's usually part of a larger project. And with insert cursor, even more so, because in order to insert into something, you have to have existing data sets. So things that often get done in conjunction with insert cursor, now this will not be a cumulative list of everything. This is just kind of a more often than not a common list of things that you might see. You're often going to see a check to see if data exists, specifically if you're working in the geodatabase model. Because if you're working in the geodatabase model, your overwrite output, while it will allow you to overwrite individual feature classes, it does not work on the full geodatabase itself. If you need to constantly have your code recreate a file geodatabase, you need to check for its existence and then delete it in order to move on. The other option is that you write your code once, you create your file geodatabase, And then as you're going through testing, if you don't want to constantly recreate it, you can comment out those lines of code so that it stays in your code so you can see it was an important part of your project, but it moves past it in the further iterations of your code. And then, like I just mentioned, if you're needing a geodatabase to be created to hold your feature class that you're going to update or to hold a new feature class that you're going to create, you oftentimes need to create a new file geodatabase. And here is a snippet of code that does these three things. It's checking to see if a geodatabase called wildfires exists. If it does, it's going to delete it and tell me that it existed and then got deleted, and so that I can recreate it. And then this line here, create file geodatabase management, is going to go ahead in my current workspace that's being held in the workspace variable. It's going to create a new geodatabase called wildfires. Now you do want to be careful with this, because if your geodatabase has a bunch of information in it, you don't want to delete it. But if it's something that you're creating new within the confines of this one project script, oftentimes this is something that will help you with the constant running of your program as you're building it and testing it. Additional things here. So I just wanted to show you the syntax of create file geodatabase management. So the out folder path, which is our workspace variable, and the out name, and then the version, which you don't need to worry about because that is an optional parameter. Rounding out this list, we have create feature class management. So in order to use Insert Cursor, you have to have something to insert it into. You're either going to be adding records to an existing data set, or you're going to be creating a brand new data set to populate from scratch with the Insert Cursor. So here we're going to look at the snippet of information that would be used to create a feature class. We're also going to look at the syntax of create feature class management and just remind ourselves about it. So it has a requirement of an out path, which is typically our workspace, an out name. So this is going to be the name of the feature class that we are creating. We're going to always tell it what the geometry type is. And also, because you are a well-trained GIS individual, you know that no GIS dataset should ever be created without a spatial reference. You must pair the creation of a new geodatabase feature class or shapefile with specifying what the spatial reference of that data should be. So more often than not, we grab the spatial reference by using the spatial reference method and putting in the WKID, which is the well-known ID. So here in this line of code, I have set up a variable called spatial ref to hold the spatial reference information that is associated with a WKID of 4326. How did I find 4326? Well, I know that my data needs to be in geographic coordinate system, so GCS WGS84, because I'm going to create a new data set using raw XY latitude and longitude decimal degree values, which are synonymous with geographic and WGS84. So I just went out and I searched online for the WKID for geographic coordinate system WGS84, and there's going to be lots of resources out there. Some of them are going to be from Esri, some from other vendors, some from the federal government, but there you will eventually find a place that lists out for you the WKID for the coordinate system that you need. So for GCS WGS84, it's 4326. So I'm going to populate that into my spatial reference method here, and I'm going to use that spatial reference variable in the optional parameter of spatial reference and create feature class management. Notice how you're using your placeholders here to skip over these particular other optional parameters that you do not need in your code. All right, moving on from there, oftentimes you also, once you create the feature class, need to add fields to the new feature class. So that's done with arcpy.addFieldManagement. Here is a snippet of code that goes through and adds 2 fields to our same Fires 2018 feature class. If you look at the syntax for this particular tool, it requires an in table, which is going to be our geodatabase feature class, a field name. This is the name you're adding to your feature class right here. You need to tell it what the field type is, and then you have a set of optional parameters. Oftentimes you can skip over field precision and field scale for a text field and go straight to field length. It's always a good idea to give it a field length explicitly so that it doesn't get too big within your data set. And then after each of these, I just have an arcpy that get messages statement for the code, simply because as it's adding fields, it feels good to see the messages that come out of that tell you that the field has been successfully added to your feature class. Once again, you've seen a workflow similar to this with update cursor and search cursor. There is a typical workflow for all of our cursors. So this is going to feel very similar, even though it's a different type of cursor. And that point is very important because we go through basically the same type of logic with most of our cursors, just slightly different things are happening along the way. So we do need to set our insert cursor for the table and the fields, including our geometry token. So we're going to open up an insert cursor with the with statement, tell it what feature class we want to be getting write access to, and then list out all of the fields, including the geometry token that we want to work with. Set up a for loop to iterate through so we can add multiple rows based upon what's being held in the cursor. Write a statement saying what the field values will be for each row. And then using the insert row method to physically do the inserting to the row with the new field values and the shape geometry. It's this final statement with insert row that does the actual data updating and the actual editing of your data set. Here we have a portion of code that's using the insert row method, and here we can see how each of these steps are paired with our code and what they look like in an insert cursor statement. We will talk more specifically about what's happening within this for block in your hands-on exercise as you move on in this module. So I'm not going to go over all of this. What I'm going to highlight is each of those 4 steps that you just saw in the previous slide. So here up at the top, you can see that you're setting your insert cursor for a table and fields. The table we're using is a geodatabase feature class called Fires 2018. And then in the tuple of the fields that are necessary for our insert cursor, we have the geometry token listed first, and then just 4 fields that we are going to be working with within Fires 2018. So these are fields that exist in this data set, and we're opening them up for editing so that we can put the cursor in there and put information inside of that. Next, you see a for loop that's going to iterate through the individual cursors. Notice there's a lot going on in this for loop, but down here we're going to focus on the portion that is specific about the insert cursor down here at the bottom of the for loop. So this is where we are going to be iterating and adding new rows and updating their information as it works its way through all of the records. So this is writing a statement saying what the field values will be in the row, including the geometry. So here we're setting up our row value variable to be a tuple of our geometry token. So we've opened up shape at XY, which means that the insert cursor is expecting an X and Y coordinate value. So we've stored those numbers inside of variables called longitude and latitude. We also know that we want 4 fields to be updated, and down here you can see, since there's no quotation marks around here, apparently we have stored the information for this row for each of these 4 fields inside of variables called name, category, method, and date. Notice that the order of these need to be in the same order as your insert cursor, because it's going to go in this order to populate the information into each of the fields in your data set. Again, I just like to print the row so I can see what's going on. And then you're going to call the insert row method for your cursor and populate it with what's sitting inside of this tuple. And then that is what's going to write this information into your data set. So before we move on, I kind of want to put this particular snippet of code into context so that you can see what this looks like when it gets done. So I could have just ended there on that, but you really wouldn't have seen the full come to fruition of an insert cursor. So that portion of code that you just saw is from a code whose purpose is to take a CSV file with XY coordinate values and other fields in it and create a new feature class within a geodatabase from the rows in that particular CSV file. You can think of this as what you would do in ArcPro as adding a table that has X field, a Y field, and then additional attribute fields, and you would right click on it and you would say display XY coordinates, or you would go to the toolbox and grab that tool, display XY coordinates. And that's the tool that creates a point data set feeding off of that X and Y, and creates it from either a text file, a CSV file, or an Excel document that has that information. So that's how you would do it in ArcPro. In ArcPy, the typical operations you want to do are you need to create a new file geodatabase if you don't already have one that can store the feature class. Create a new feature class with the proper spatial reference. And if you are feeding into the insert cursor raw latitude and longitude values, so your X and your Y, those decimal degrees, you always need your spatial reference to be a geographic spatial reference, because that's the spatial reference that understands those raw latitude and longitude values. You then need to add the fields to your new feature class that match what's in your CSV file. Open the CSV file in your code. So this is hearkening back to what we learned when we were just focused on Python, how to open files and print out what's inside of them. So you're going to see that same type of logic come back here in this particular portion of the class. Open the file and then use the insert cursor and to go through each of the rows in your CSV file, populate your cursor object, and then insert that into your new feature class. Here is what that CSV file would look like if it's opened up in Excel. Remember, CSV files are comma delimited files, but they open up nicely in Excel. And Excel just takes wherever there's a comma and puts it into a separate field. So this is a nice way to look at your CSV file. And you can see that we have X coordinates and Y coordinates very clearly in decimal degrees, and additional information in this CSV file that we also want to have in our GIS point data set. Here is the entire code without extra comments, so very bare version of it, where you would go through all of the steps in order to do what I just listed in that previous slide. So we're not going to talk through this individually and in detail, because in your hands-on exercise here for this section, you're going to create and build this script. And there's lots of information in the Canvas site about how to and why we do each of these individual lines of code. But I want you to see the full suite of the code, and then I want you to see what it creates. So the best way to see the output of an insert cursor is to add it back into a GIS desktop software. So here I have just added in the FIRES 2018 dataset after the script has run. You can see that I have a series of points in this dataset. You can see my shape field clearly says point, which was created from those X and Y coordinate values. I have my incident name, feature category, map method, and create date, which were fields that I created in this data set and then just populated with the same information from my CSV file. You can see over here that I had created a file geodatabase called wildfires. I had created a feature class called FIRES 2018, and that's what this insert row went into. And finally, I can also confirm that my spatial reference was properly set to be WGS 84 within geographic up here, geographic coordinate system with a datum of WGS 84. And even in here in the Esri software now, they will list out your WKID for you there as well. So all of these things have been put together to create a very standalone GIS data set that is in the proper spatial reference, that draws properly in the coordinate space and knows what it is and knows the information that is inside of it. So that is the goal. That's to create new data, and the best way to go in, verify that you have done that, is then to just add it to a desktop GIS. All right, once again, that was a lot of information. So your next step is to move on to the hands-on practice, where you're going to get to play with Insert Cursor and write the script that you've seen in this particular presentation.